Thank you, Bas.
Does this work? Can you hear me? I'm sorry, I tried learning Spanish before this, but I failed. So I'll do it in English. Let's see if this works. Okay. Is it supposed to be on this projector too? Okay, excellent. Let me see. Okay, good morning, everyone. I'm Bas Vodde. I'm not going to give any longer introduction, just as Javier already said, I'm one of the co-creators of LESS, and the topic that I'm going to talk about is also very LESS related. Let's see if this works there. So the title of the topic is Maximizing Dependencies with Interdependent Teams. And I've chosen this title because very early on and in the Agile community, people always looked at when we start scaling up, we need to have more of that one team dynamic. So therefore, the idea was always we need to try to get many as independent teams as possible, which don't have any dependencies with each other. And I've thought that myself for a very long time. And a couple of years ago, I considered that maybe that's the wrong approach. And I changed that approach and stopped looking that way. And instead of trying to look at when you have more than one teams, trying to get the teams to be independent, we would like to actually have the teams maximize their collaboration. And instead of trying to remove dependencies, we would like to look at dependencies as an advantage and try to maximize those. And during this talk, I'll explain a little bit more what that means and what kind of dynamics you can create with that. Now, for a long time already, I've started using storytelling as a way of giving presentations, because I noticed stories are easier to understand. It also keeps people awake, and they're good to remember. Like, I'll start off with just a very short story, which I know within the LESS community has been a favorite, which is a story when I've lived in Singapore for a long time. And a couple of years ago, my oldest son had his swimming lessons there. I'm Dutch, and of course, swimming for Dutch people is very important. So we went to his swimming lesson, and we drove back, and we were stuck in traffic there. And my son was sitting in the back, and he says, "Papa, I want to go faster." And I said to him, "Well, that's nice, but we're stuck in traffic, and we can't go any faster." And then he looked at the other side of the road, and there was no traffic jam at the other side of the road, so cars were going pretty fast there. So he pointed to the other side of the road, and he said, "But they are going faster." So I told him, "Yeah, but they are going in the wrong direction." Right? We have a choice here, which is we can either go slowly in the right direction, or we can go very fast in the wrong direction. What do you want to do? And he thought it over a bit, and he said, "I want to go very fast in the wrong direction." And that night, reflecting on my day, I suddenly realized that that small story is like the perfect description of our industry. Because over and over again, when I work with organizations, they want to increase velocity, increase output, etc. But they never or rarely wonder whether they're going in the right direction at all. So one of the aims with LESS is not so much focusing on improving efficiency, velocity, and things like that, but first making sure that we're going into the right direction. Now, in this talk, I'll experiment with another way of storytelling, because one of the drawbacks of storytelling is that usually one story has one point. And I wanted to bring multiple points together, and I didn't have an experience or a story that would share that. So one of the things I've done is I kind of combined all of the stories and experiences that I have into a fictional one. Which then is not really fictional, but just a combination of experiences. And I decided to do that with using Lego. So I'm going to go over a typical, for 10, 15 minutes or so, a typical less dynamic of multiple teams working together. And I've set that up in Lego. And again, I could do that with my oldest son for as long as his patience lasted, about 5 minutes. The other 2 days was by myself. So in this story, I'm going to use 5 teams: Space, Criminals, Lake, Halloween, and Power. And you need to pay a little bit attention now to their uniforms. So try to theme the uniforms based on the team they are, so that you can see which team they are when I'll explain some of the dynamics that they go through. Okay. Now, we're going to just run through a sprint, but in order to make this a story, we also need to have some kind of product they're building. And the last product that I've been involved in as a developer, last 2 years, is a product for managing educations and universities. So therefore I was a little bit biased, and I decided to take a course, university management-like system. And in such a system, a product backlog would typically look like this. This is just the top of the backlog. Now I do want to point out something which is very common for larger products, is that the top of the product backlog has small items that teams can easily do within one sprint. However, the items together form larger themes. And what happens at the top of the backlog, if the teams are working on multiple themes at the same time, then they start mixing a little bit. So if you look at this, we have some roughly 3 themes going on here. We have the adoption of new technology that is going on. We have the direct course registration through a link, and we have the integration with the scheduler. So we could say there's 3 larger themes going on at this moment. These themes have been broken up in smaller items, and in top of the backlog, those have been not put into the higher theme priority, but in the smaller priority. So that's what you can see here. So course registration, scheduler, and new technology adoption. Now, in less, whenever you start a sprint, less roughly works similar structure as Scrum. When you start a sprint, you start off with Sprint Planning 1. And Sprint Planning 1 is one of my favorite events. What happens in Sprint Planning 1 is we have all of the different teams here. So you can see all of the different teams here. And this thing on the middle is a large table. And we've basically just printed the top of the backlog, which you just saw there. And we've put them on the middle of the table. Now, the goal of Sprint Planning 1 is for the teams together to look at the top of the backlog, to talk with each other about the top of the backlog, and to decide which of the items, which of the teams are going to work on, and how the teams are going to help each other out during the coming sprint. So what you see here is one of the weirdest ways I've seen this done, is you see around the table we have one representative of each of the teams basically talking to each other, but then behind them there's the rest of the team, and they're kind of talking to each other, how they can help, what items they want to pick up. And you can see there's also some people across the teams talking to each other and discussing how they're going to work. Then what will happen is that one of the teams, say the criminals teams, will say, well, the last sprints, we have worked on this theme of course registration. And when we look at the top of the backlog, we see there's new items coming related to course registration. And since we've worked on that in the past, we propose that we take up the top item from the backlog related to course registration. And then another team, say the beach team, they were called the beach team, right? Let me double check. Lake team, sorry, I forgot the names already. the lake team, the swimsuit team, they might say, hey, but wait a second, when we looked at the backlog, we see there's a lot of features related to course registration coming. And because of that, if we only have one team that is very knowledgeable about that, we'll be in trouble in the future. So therefore, we'd like to pick up an item related to course registration. Right? And then the criminals team might say, you're right, that makes sense. We'll need to work more on this. And they together might look for an item. That's a good item to start this new topic for the other team. And they'll talk about how they're going to work together. For example, the criminals team might decide to review the code, or have one person join the other team for one sprint. Or there's lots of different ways or different things that the teams can work together during a sprint, and they'll figure that out during sprint planning. So what happens during sprint planning, they basically take one of those items at a time, talk about it, decide which of the team wants to work on that item, and then they decide together how the teams are going to collaborate and help each other out during this particular sprint. They'll take then, the end result of this is that all of the teams have the items they're going to work on, and they'll take that then to sprint planning too. Now, before I go there, let me point out one very key thing in LESS that so far I've left implicit, which is we have one product backlog for our product, not per team. If you want the teams to avoid working together, then making one product backlog per team is one of the best ways of doing that. So we just have one backlog for the entire product, and that's where all of the teams are working from. Okay, so they take that to sprint planning 2. And the first thing that happens in sprint planning 2 is a shared design session. Because in essence, sprint planning 2 is about figuring out how you're going to implement the items, which is about software design. So what you see here is a large whiteboard. And again, all of the teams having a very brief discussion about what kind of changes they need to make within this system in the coming sprint. And this usually only lasts about 15 to 30 minutes, because we're not going to obviously talk about all of the changes they need to make. That would take too long. But one of the things that we would like to discover here is when multiple teams are going to work in the same components, the same architectural units within the system in the same sprint. Because when that happens, they might have what we refer to as shared work that both teams need, and they'll need to then figure out how they're going to collaborate within the sprint. So this is only 15, maximum 30 minutes. And after that, each of the teams, usually in the same physical space as this, will go to their own area of the room, and they have their sprint planning very much as you would traditionally do this within Scrum. So each of the teams are talking about how they're going to implement the items and what kind of tasks they'll need to do to have the items implemented within the system. You do see there's some cross-team collaboration also going on here, and this is especially related to this shared work, where the teams would need to figure out which of the teams is going to plan this within the sprint. So they might scream to each other saying, hey, are you guys going to make this change in the database, or is it better that we plan that within their sprint? That's the kind of collaboration that happens here. Also, we can see here, and you'll see him also in, whoops, that was the wrong button, in the rest of the presentation, the guy to the right with the red cap and the coffee mug, that's the product owner. And just to be clear, also there's only one product owner for a product. You do not have a product owner per team. Having a product owner per team is an exceedingly bad idea. And I'll explain a bit later why it is such a super bad idea. So therefore, we just have one product owner. And most of the less events, he's as involved in the event as you see him here at this moment. Okay. Now, the sprint starts, and the teams start working on their items. And what we see here is the office space. In one of the adoptions, I've worked in an office space exactly like this one, and it was just wonderful. So we have different teams sitting on their table. So each team has their own table, which is just their team's table. And each of the teams working on the same product, they're sitting all next to each other in the same space. Each of their team has their own whiteboard. Now, one of the things that you will see here, which is common in a very collaborative, less way of working, is that all of the people are constantly working together. It is rare to see one person working by himself on something. It's almost always a pair or people talking in some kind of discussion. Now, one of the interesting things of good less adoptions is that you often cannot figure out which people belong to which team. Because there's so much cross-team collaboration going on that if you're just in the office space, it's not possible to figure out, oh, these two people belong to that particular team. So also cross-team pairing, for example, is a common thing. Now, as the last event, in the middle of the sprint, the teams together have what in less is called a multi-team product backlog refinement. And in a multi-team product backlog refinement, all of the teams are going to together look at the next couple of sprints of the product backlog, try to clarify those features. They do not decide which teams are going to work on what items. We explicitly don't want that because that's going to be done only in Sprint Planning 1, as I talked about earlier. And therefore, one of the weird dynamics that we typically use in a multi-team product backlog refinement is that the people work in what we call mixed up groups. And if you look carefully and you exactly remember which person is in which team based on their uniform, you can see that now each of the groups that you see is actually a combination of at least one person from each team. Right? So therefore, what happens here is the product owner to the right there, he's projecting the product backlog, basically takes the first item that needs to be clarified of the product backlog, and then says, which people would be interested in clarifying this particular item. And then from each team, there will be at least one person who volunteers and say, yeah, we are interested in figuring out what this means. And they form this mixed up group. They go to a whiteboard and they'll talk about that, ideally with users and stakeholders, which you would like to have present in this event also. And then the product owner picks up the next item and says, who is interested in clarifying this? And they form another mixed group, etc. The mixed groups tend to talk and collaborate for about usually 30 minutes or so, and then we'll bring everyone back together, we'll summarize them, and we'll repeat this until enough of the items are clear for the next sprint to start. Now, the effect of a multi-team backlog refinement is that of that one product backlog, each of the teams has one member that was involved in deeply clarifying each item of the product backlog. And because of the summarizing, each of the teams has a larger view of the whole product, of all of the items in the product backlog. Now, this way of working is one of, at least my personal favorites. Being in this environment is very enjoyable to me. The amount of learning and team collaboration is very nice. But this kind of environment doesn't just happen. You need to put a couple of things in place to enable this. So therefore, the rest of this talk will be about, okay, so that sounds kind of like a fairy tale, but if you would like to make that reality, what do you need to do within your organization to create an environment of close team collaboration like this? So, enablers. And the first one that I'd like to talk about is not so much something you need to do, but what I always call the two journeys that teams need to go through when they adopt less. So if you have a traditional team, and then now when I say traditional team, I mean like a Scrum team, not like a waterfallish team, because I assume nobody does that anymore. So if you have a traditional team, then and you start adopting less, then often the teams will need to go through what I call two journeys. The first one is the journey of coming from somebody telling you how you should work to a self-managing team, the team figuring out by themselves how they work as a team. And in my experience, this usually takes at least 6 months for a single team, because this is quite a shift in thinking and taking responsibility. And I always love this particular part, especially because one of the things that happens is that teams that are being told how to work, you can recognize them by complaining, because they often complain about something they must do that somebody has told them that they must do that. But once they start moving towards self-managing teams, they get to make their own decisions. But in the beginning, teams don't recognize that yet. So they'll be often complaining about their own decisions, because that habit of complaining doesn't yet go away. And then you'll just have to remind them that they are the one who actually made that decision. Now, the second journey is more or less specific and perhaps harder, is the journey from a programmer to a product developer. And the naming is kind of awkward here. But what I refer to as a programmer here is that as a developer, you expect somebody to tell you what features you need to build. And traditionally, most of the people, they expect somebody to tell them the features, to give them the specifications, to clarify all the stories for them. But in less, we don't want to have that. Instead, we want them to be product developers. And what I mean with a product developer is understanding that you're building a product to solve a problem for a certain customer and user. And as a developer, you need to understand your customer domain, and your user's problem. And whenever your customers say, I would like to have this feature, then you don't implement the feature that they tell you to implement, but you stop and think back and wonder, why would they want a feature like this? What is the problem that they have? Right? And then once you understand the reasoning for a certain feature, then you can use your knowledge, the team's knowledge of technology, to try to see if there happens to be a better way of solving that particular problem. right? So therefore, a programmer, a traditional team, they just, they see their job as, writing code, implementing features that somebody tells them they need to implement. But a product developer sees themselves as building that product, solving that problem for their customers. This change also takes a long time. And I want to point out, this change will not happen as long as you have a product owner for your team. Because the product owner for your team will likely clarify the features for the team and therefore will actually prevent the team to grow to become product developers. Now we'll see these two journeys come back later. But now let's look at some of the enablers, and we'll start off with some of the principles. So in LESS, we have 10 principles that guide our work. And one of those principles is whole product focus. And whole product focus is we would like all of the people working on a product to not only look at their part, but we would like them to understand the whole product. In a way, they need to prioritize the product over what they are working on. Now, you see a whole product focus come back in the story that I just mentioned by having one product backlog and one product owner. Having one product backlog, one product owner with multiple teams working on it makes clear that all of the teams work on that product. When we don't pre-select the items for the teams, and this is key, right? Before a sprint planning, the team of the backlog, the entire product, don't know what they're going to do yet. Right? So therefore, they must have that broader product focus rather than just looking at their part. Now, also, a key thing in LESS is looking at what your product is. Right? When we talk about a product, we think of it from our end customer's perspective. Right? The typical LESS way of defining your product is go to your end customer and ask your end customer, dear customer, what do you think is our product? Now, this is fascinating because in most products that I've worked with, the customer's view of the product is actually very different than the internal view of the product, especially when you work in organizations where teams started looking at microservices or applications to be their product. But your end customer doesn't care about microservices and applications. They just want to have functionality that helps them solve problems. Right? So we like to constantly look at that end customer view, not define our structure based on technology, but look at that from our end customer. Also define our products from our end customer's perspective. Now, when you try to use LESS, typically there's two large changes that will happen. The first one is getting rid of product owner per teams and product backlog per teams. And the second one is the change from a component team structure to a feature team structure. And feature teams are an absolute must when adopting LESS. LESS without feature teams makes no sense. Now, what does this mean? I contrast the two ways of organizing your teams here. The that way, I don't want to get confused with left and right when I'm standing here. The that way model is the component team model. And a component team model basically means that we organize our teams around our architecture. When people say things like they need to be organized around Conway's law, which LESS consider to be nonsense, then you are looking at component teams. So therefore, each of the teams owns a part of the architecture, part of the system. So we have here component team A, which owns component or service A, B, C, C, etc., etc., etc. Now, there's lots of problems to this way of organization, but I'm not going over all of that. That would be a talk by itself. But one of the key ones is that end customers don't require features related to services or components. So therefore, if you structure this way, you have dependencies between the different teams. So if we look at the product backlog, the first item will require work from team A and team B, because it requires a change in component A and component B. The second item will require et cetera, et cetera, et cetera. Now, this by itself is not really a problem, and so far a bit conflicting with the title of this talk, because I said dependencies are good, and now I refer to them as actually not so good, because this type of dependency is one that you want to avoid. And I'll get back to that later also more. We refer to these as asynchronous dependencies. And you can see that with what happened to item 4 here on this picture. Because item 4 will require work from component team A and from component team C. So what will now happen in practice is that the next sprint, team A will work on item 1. Because from their perspective, item 1 is the highest priority. Team C, though, they will work on item 4, because item 4, from their perspective, is the highest priority. But in order to actually have item 4 end-to-end implemented in the system, it also requires work from Team A. But the next sprint, Team A will not work on it yet. Because from Team A's perspective, this feature is not the highest priority. So what will now happen is that Team C will implement their part of this feature. They'll leave that half integrated within the system, and a couple of sprints later, Team A will implement their part of this feature, and they'll try to integrate that with the work that Team C did a couple of sprints ago. And of course, that never works. So then Team A will start interrupting Team C, and Team C will be annoyed about that, because from their perspective, they've completed that already 2 sprints ago, so they don't really want to work on that anymore. So you get this conflict between the teams related to these features. Now, the problem here is that this kind of dependencies is what I mentioned already, is what we call asynchronous dependencies, where the dependencies don't happen at the same time. Now, unless we adopt what we call feature teams, and feature teams means that we stop organizing the teams around the architecture completely. In other words, there's no more mapping between the team and your architecture, your system. You can quickly recognize that by the teams having meaningless names, right? So I've been, for example, a member of the PowerPuff team for a while, and believe me, there was no PowerPuff service or PowerPuff component. There was just no link anymore, so teams make up whatever names they make up. So therefore, here we have Team Wei, Shu, Wu, and for these feature teams, each of these teams, they just pick up one customer-centric end-to-end item from the product backlog, and they're responsible for making whatever change they need to make in the system for getting that to work. So therefore, maybe Team Wei will need to work in component A and B in this sprint in order to get their feature to work. And then if Team Shu takes item 2, maybe they need to work in component A and C this sprint in order to get that feature to work. Now, we still have dependencies now between the teams, but the dependencies now relate to multiple teams working at the same time in the same components. Now, these dependencies is what I like to refer to as synchronous dependencies. I think I have a slide for that even. There we go. So synchronous dependencies are when two teams are dependent on each other, which I'll get to in a moment, but the dependency happens at the same time. So there's no context switch. Now what happens in these situations is that the dependencies actually become an opportunity for collaboration. Right? If team Wei makes a change in component A and team Shu makes a change in component A, all at the same time, then it suddenly becomes a benefit of these teams to work together because they might use each other's work or at least make sure that they don't break each other's work. But there's no switch, there's no context switch because they're still focused on that one particular component, unlike the dependencies with component teams. So, key point here, asynchronous dependencies cause interruptions, and interruptions cause conflict between teams. And this causes the teams to request to become more independent, because we don't want to be interrupted by the other team during the sprint. Right? So they try to avoid these kind of interruptions by fixing the interface or whatever ways to avoid the teams to talk to each other. But synchronous dependencies, they promote collaboration. They promote learning between the teams, and they're actually a good thing. They're something you'd like to maximize. So that's what we want to have. We want to have interdependent teams. To try to clarify the title of this talk, we don't want independent, isolated teams, but we want to have this kind of synchronized dependencies where the teams are collaborating and are constantly learning from each other. We'll look at cross-team collaboration as a learning opportunity for both of the teams. Now, on one hand, I've said you need to avoid dependencies, and then specifically asynchronous dependencies, and you need to encourage other dependencies, and then specifically synchronous dependencies. But that's not the complete truth. Right? There's a better way of looking at that. And in order then to also clarify why we say you want to maximize the dependencies, we'll look at what dependency actually means. Because we often use the phrase dependency to mean different things. And one of the things that we use it for is, if you wish, the literally meaning of the word, which is we depend on another team, meaning we cannot continue until the other team does something. Right? And those kind of dependencies you definitely want to avoid. They cause frustration and annoyance when you're just sitting and waiting for another team to finish something. Those are no good. However, we also refer to dependencies when we talk about teams are working together in shared work environment, right? Two teams are making changes in the same component, and therefore they have a dependency. But they're not, they're not dependent on each other. They're not blocked by each other, right? So if if the other team doesn't work in that component today because they don't like it today, then that's not a problem for any of the other teams. They'll never be blocked or have to wait for the other teams. Right? And those kind of dependencies are actually good. These are dependencies you'd like to maximize. Because if you maximize these dependencies, then that dramatically increases the cross-team collaboration. And then you'll get very weird things, because then, sorry, I've forgotten about this slide. I thought it was going to be very smooth, also that one. Then all of the teams together start working kind of as one team. And that's what you saw in this 5-team scenario, is that the 5 teams almost work as if they're one team. They're not one team. They all have their own identity, but the in-team collaboration is almost the same as the cross-team collaboration. Just as easy as you would go to your team member to ask, can you help me with this and this and this? The same easiness goes when you go to another team's team member and say, can you do this and this and this? There's no more barriers between the teams. Now, a key thing that happens if you adopt feature teams, a key other thing that happens, is that as a team, you have much more choice. And it took me actually a long time to realize this. What happens if you're in a component team structure, that whatever work is related to that particular component becomes your team's work. You have no choice. But what happens within feature teams is that you have, remember the sprint planning one, you have the top of the backlog, and the teams simply talking to each other. And one of the team might say, gosh, you know, we've been working on this new technology upgrade for 4 sprints already. We're sick and tired of that. I don't understand Spanish. I don't know what the sign says. Okay. I guess that means 20 more minutes? Anyway, so now you have a lot more choice. The teams are actually together deciding, so the team can say, we're now this sprint going to work on course registration because we want to work on something else. Also, another thing that happens is that teams do accidentally specialize. And again, this is a topic of an entire talk again, but I gave an example here. So when during the pandemic, I actually joined a team as a developer for 1.5 years. Team Hub was the team I was in. And one of the things they made is they said, they gave a preference of what the team will work on. So they said, we like working on features that are complex, we like working on features related to students, and we like working on UI features. So therefore, in sprint planning, they would actually look at the ones that they would prefer doing. And other teams had other preferences. And of course, this was not the only thing they did. If they needed to do something else, they would pick that up. Now, one of the things that starts happening also is that the teams together start picking up very large features. And they work on it with, for example, 5 teams at a time. Right? So in one company I've worked with, the customers do different larger requests. And traditionally, they would give one of the requests to one of these teams. And each teams would work on that independently. But now they've switched to start using less. So they take one of those larger feature requests, and then all 5 of the teams work on it for 2 sprints, and then it's done. And then they pick the other larger feature requests. So the amount of customer requests that are in progress at the same time is much less, which dramatically increases their cycle time and their ability to change its direction. I'm not going to talk about that. Except for maybe, hey, stop. That is wasting my time, of course. There. Read this book. It is really excellent. So one of the things that the teams will need to learn is to work on build up functionality incrementally. And this is often one of the hardest things that the teams will need to get. Because if you want to work the way I just described, you need to, on a technical level, have really high-end practices. Because without that, it actually doesn't work. So the people need to learn how to work in an incremental way. They need to know how to work in a way so that they can commit to the main branch many times a day. And no pull request, no feature branches, just directly to trunk many times a day. Which we refer to as continuous integration, but continuous integration eventually became to mean an automated build tool. So now it's called trunk-based development, but it's the same thing. And one of the things that also starts happening is you start using a technique we refer to as communicating code. So you actually use the changes that you make in code for people to discover when teams need to collaborate. Right? So this is in the team that I worked with. You can see some of my commits here, the only ones that are in English. What we did here is we used, unfortunately, Microsoft Teams, but we hooked that up to GitLab so that whenever somebody committed, it would go bling, somebody committed. And then whenever another team started working in the place where we are working, we would immediately know that. Right? Since they always commit small changes and always do that on the trunk, so we would immediately get to know that. So we would say, hey, you guys are working on the same thing as us. Maybe we should talk about that a bit. Don't branch. Another good practice is to start having mono-repositories. And this is the last of the practices that I'll cover, which is don't have many small repositories, but create just one huge repository and put your entire product in there. Having multiple repositories causes hell in versioning and trying to synchronize, and it again puts the teams in different silos. Google is famous for this concept where they have all of the code in the company in one repository. Okay, so in less, we want to maximize dependencies, meaning we want the teams to have the maximum amount of shared work so that they can learn and collaborate with interdependent teams, where working cross-team becomes as comfortable as working in-team. In order to achieve that, you have the teams work on one product with one product owner. They closely collaborate. There's no link between the teams and your architectural structure. And you continuously integrate cross-teams, and you'll put everything in the same repository. And I'll believe my time is up. So I'll leave it here. Thank you very much. Do we do questions or not at all?
Thanks, Bas. Thanks. Thank you. All right. Bueno. Disfruten la conferencia.